Awesome. Thank you, Andrea. Um, to be formal, good evening, everyone. Thank you for attending tonight's meetup. In the next 30 minutes or so, I will discuss about what is Terraform, how it can be used to manage your infrastructure and also integrated with Azure Pipelines. A few words about me. My name is Dimitrios. As I mentioned before, I live in Manchester and work as a full-stack.NET developer for Cox Automotive. As far as my adventures, I blog on slowthicode.com and you can also find me on Twitter. I've started my career around 4 years ago developing solutions with ASP.NET for a Swiss company working remotely from Greece. And this is today was my first day of work in the UK last year. Just wanted to mention that because I was happy for that. Moving on. This presentation will be in two parts. We'll start by discussing Terraform, its syntax, its features. We'll have a demo from my local machine, and then we'll move into the Azure part of the presentation where we'll see how we can automate it a bit more using the Azure pipelines. The end state of the first part will be an Azure web app running an image from an Azure container registry. And to do that, it means that we'll have to spin up a resource group, an app service plan, and of course, the app service. And note at this point, I mentioned an image from the Azure Container Registry. This is an image I have pushed in my own container registry, and I will use Terraform to set the app settings of the app service so it can connect to my to my container registry. This is to demonstrate one of the features. So let's start with the theory. Terraform is a tool to build, change, and manage your infrastructure in a safe and an efficient way. To do that, the configuration files are used which describe the state. And Terraform uses these configuration files to create an execution plan which will run and bring your subscription to the desired state. Configuration files use a language called HCL, or the Haskell programming language. It's something meant to be human readable and editable as well. It's similar to JSON, say. And also there is support for multiple environments and major cloud providers. I've mentioned the word state a few times before, so is the image on the left clear?
Yeah, looks good.
All right. So to start working with Terraform, we have to initialize a directory. To initialize a directory, we have to also define where we will store our state. The state file can live either on the developer's work machine, it can live on the repository, but because the state file contains sensitive information like resource IDs, the settings I mentioned before I will set, and other information that we don't want to end up anywhere, the suggested approach will be to use a storage account. As you can see in the image, in lines 1 to 6 for the backend for the Azure Resource Manager, I specify some properties like the resource group name where my storage account lives, the storage account name, the container name, and the key that will be used as the name of the state file. Also, different workspaces can be used to manage and create environments, and we'll see in the local demo what this means. This is an image from the container that we specify on the backend, and it just every file you see there is a different environment using the same project, but with different variables. And now let's jump into how a configuration block looks like. It consists of 3 parts. First is the resource. We use the word resource or the word data depending on how we want Terraform to interpret this block. So using the word resource means that for Terraform, it will go and create our resource in the account. But if we're talking about using the word data, it means that it will go into the subscription and look for that specific resource. So in the case that I had data instead of resource there, Terraform would look for that specific resource group. I'm also setting some tags, and you see some weird string interpolation going there. We'll get to that in a moment. This is the block for the app service plan. Now, it's similar to what we had before, but The second part of the declaration consists of the resource type. Before it was an Azure RM underscore resource underscore group. Now I'm using the Azure RM underscore app service underscore plan. And next to it is the name. This is the name that we use to reference this block inside our Terraform configuration. What's interesting also here is the way I'm setting the properties for the app service plan. I'm not using the name, location, and the resource group name. I'm not using any hard-coded values for this, and instead I'm referencing the resource group from before. So if you see the way I'm referencing it, I'm using the resource type Azure RM resource group dot the name of the resource group, and then the property that I want. Even for small projects, I really find this extremely useful because hard-coded values are never a good thing. And I'm also setting the kind that I want a Linux app service plan and the size. Both the kind and the size could also go into into variables, which could then be used to specify the plan and specify different values for different environments. For example, for your dev environment, you would like to use maybe a basic tier, but for your production environment, you will go to a premium one. Let's move on. Here are the variables I have mentioned before. Let's take a look on the two last variables, the ACR admin password and the ACR admin username. When I'm using those variables in the configuration file, I can specify default value, but I can also use explicit files, JSON files that set the variables depending on the workspace I'm working with. So if you can see on the first variable, I'm declaring a variable named environments, and it's a map. So how this would be used? In the case that I'm working on a workspace named staging, when the plan would execute, if you see the second part of the interpolation here, var.environments terraform.workspace, it will look for the key of staging, and then it would append the S at the end of my resource group and everywhere where this is used. So this is the way that we can define different different environments with different environment files. So after the configuration is completed, the next step will be to run the plan command. The plan command will compare the change configuration with what is there right now on the remote state, and will work out what needs to be created, to be destroyed, or be changed. A plan validation also happens before the plan is laid out in front of you, and if anything is not wrong, or if something is missing, for example, you're using a variable that you have not defined, it will shout at you. And once we are happy with the plan and everything looks okay, it's a time to run the apply command. After running the apply command, Terraform will start provisioning the resources, and in a few seconds to a few minutes, this will be ready. I found really great that this can be done in minutes. To give you an idea, the Terraform project I'm working with on my work takes around 9 minutes to execute. So think about how much time I need to go and do it manually from the Azure portal. Not one time, not two times, 4 different times for 4 different stages. What else can we do with Terraform? If you already have an infrastructure and you don't have a Terraform project, you can start creating a new one and import the infrastructure into state. Currently, this is more of a manual task, and it's not as easy as Terraform import and subscription or the resource group name. You have to define your plan, not your plan, you have to define the configuration, and then manually, step by step, import its resource into the state. The resource blocks we've seen before can be bundled to create modules. So instead of deploying a lot of different resources, you will be just deploying one module. And another thing that I do find really useful is output variables. So in that process of creating our resources, sometimes we want to use values that we don't know before a resource has been provisioned. So with Terraform, we can refer to that value and read it or output it. Something that I have not mentioned before, and I will go back to my slides, is about the order of execution. No, actually, I'll switch back to my screen now. Okay, so this is the Terraform project we will work on with, and I will go to the appservice.tf file where I'm specifying the app service. And to let me find what I was looking for. Service, come on. Okay, I think I can find it right now, but let's move on. An important note here. Now that I'm using Terraform from my local machine, I'm going to use the Azure CLI to log into my Azure account and do and apply the plans, create the resources, and destroy the resources. When we will move this into the Azure pipelines, there we will use a service connection. For those who are familiar with that, so let me delete the Terraform folder here and go from the start. First step would be to log in into Azure. So I will go with the AZ login command. I'm setting the VS Code screen, right? Not the other screen. I did that mistake on my previous talk.
I can see the VS Code.
Awesome, because on my previous talk, I was talking for a minute or two with the wrong screen. And now you can see that I am logged in into my subscription. Just to make sure that everything's okay, I'll go on AZ account show. Yep, we're good. As I mentioned, the first step to start working with Terraform would be to initialize the directory. So I'm going to do a Terraform init. It will go and read the values we have defined on the backend here. Look for this resource group name, my storage account, the container, and that key. And as you can see now, Terraform has successfully been successfully initialized. Now that it is initialized, the first thing that I would like to do is to create a new workspace. By default, when you're working with Terraform on your local workstation, you are on the default workspace. So if I go to Terraform workspace list, you will see that I'm on the default workspace. You can see that by the asterisk next to it. The staging also is showing because on the container that I am using, I had already created the staging environment. So now let me switch to that. Terraform. Or actually before that, I'm going to try and run a Terraform plan and see that it will fail because I'm on the default on the default workspace. Maybe. Takes a couple of seconds to refresh the state. Oh, actually, it doesn't fail. Why is that? Yes. Oops. I've said before that based on the workspace I am in, I'm using this here, this variable, and based on the workspace either staging or default, I'm appending, the value. Because the default is declaring the environment, this is why it did not fail. So since it did not fail, let's see, have a look on the plan. Go from the start. So the first thing that it will create is the, not the first thing, one of the things that it will create is the app service by day.ui. And here you can see everything that it will set on that service. These are the app settings I will set in order to connect to my Docker container. A tag I am using, you can see that in the environment, it's using the default one. Because if I go to tag on the, come on. two tags here. I'm using the Terraform.workspace variable. Some authorization settings. Let's move on. Here is the app service plan. Again, with this of the type, set it and the size, the same name, and the resource group. What I wanted to mention before, and I forgot it, is the order of execution. In my plan, I have not specified at any point at which order Terraform should create my resources. And this is, I can do that, but I don't need to. Terraform can tell the way that it should create the resources. It won't try to create the app service plan before the resource group is there, or the app service before the app service plan is there. But you can also use the depends on keyword in case you want to explicitly mention this. So the plan is to add 3, change 0, and destroy 0. I also have a warning here, but I don't care. Next step will be Terraform apply. This will take a few seconds in the next step as well. And after you execute the apply command and you have the plan, Terraform wants an extra confirmation, just type yes. You could use the auto-approve switch to ignore that, which this is what we do on Azure Pipelines. We'll see that later. So now that I've given the yes, it will start creating the resources. I'll open my Azure portal on the other side. I do find this silence while Terraform is working, weird. You couldn't have that on a face-to-face meetup.
Yeah, it's different, the feedback you get online.
Everything, not even being able to see faces to understand what is going on. Awesome.
I know.
The plan is completed, 3 resources added. So now let's switch to Azure. I'm here on my Azure portal. Here are my resource groups. I'm going to click the refresh button. And here is the resource group I have just provisioned. So let's have a look on the app service of it. Because as I mentioned, I'm going to... okay, one moment. And back. As I mentioned, this app service is running an image from my Azure container registry. So if I go to container settings here, I can see that there is my registry here, although this is not exactly what I wanted to get. It should show up here. But in my configuration, my moment. Here are also the values that we've defined on the Terraform app service. Let me find the app service. Those 3 settings. The reason that those values are not there now is because when I ran the plan, I did not specify the variables. Those variables, ACR URL, ACR admin username, and ACR admin password are there, but as you can see, they are empty values. So now that I know that those values are not there, and this is my mistake, I will execute the plan once again to update what I already have there. I'll need a minute to retrieve those values from. I'm gonna set them here to win some time. I'm also going to expose my secret. and also set my URL. So now I have an updated plan and I want to apply it. I want the new changes to the new settings to show. So again, I'm gonna run a Terraform plan. This time it will be so quicker. As you can see now, there is only one thing to change, and if I scroll up on the settings, you can see it here. From an empty value, it will change to those values. So I'm going to apply this plan, Terraform apply with an auto approve. Almost. Yep. Awesome. Apply complete and one changed. So I'm going to switch again back to my app service. Going to the configuration, and now my variables here should have their values. And if I click container settings, yes, now it's working. Now it loaded correctly the settings to connect into the Azure Container Registry. It found the registry, my image, and the tag I'm using. So not the final step, one step before that would be to just start browse there and see that it's really the entity really works. Needs a few moments to warm up the app service. I think I will move on because we will see exactly the same thing. Ah, okay. And there it is. Now it is, the app service is there, it's working, and I only had to run a plan and then apply command. And the final step, because I'm finished with the first part of the demo, of course, it will be to tear down the infrastructure, destroy it. The command is Terraform destroy. I'll also use the auto approve switch. If you can see, it's destroying the resources. Destroying them takes more time than creating them. Great. Destroy complete, 3 resources destroyed. Let's validate that. I go back here on my dashboard. And you can see that the resource group I had for my day UI is not there anymore. So that would be the end of the first part of the Terraform presentation. And now I'm gonna move on to the second part of it.
Dimitri?
Yes.
Looks like there are a few questions in the chat. I can tell you if you prefer.
Of course. To be honest, I'd prefer to take some questions before and some after, because it can become a really complex process to follow sometimes.
Yeah, up to you. Do you want to wait for the end, till the end?
No, we can have some now.
Okay. Yeah. So Alex is asking if you do use Terraform in your day job, what made you pick it over IRM templates, and did you need to deploy to AWS?
Okay. I have started working with Terraform because as a requirement on the new solution that we are working. I'm not using it on my day-to-day job, but I will use it every 2 days probably. The reason why I went with Terraform and not ARM, I would say, is just personal. I'm not comfortable working with ARM templates, although I can read them. I'm not comfortable writing and creating ARM templates. And the last part of it, about the AWS. I have not done that on AWS, but Terraform supports AWS as well, and the same process applies. You might find some different bits. For example, you want to use a storage account, you will use an S3, although I don't see why you can't use a storage account, but you can definitely do that.
Oh, great. So there is Matt asking for if there is a good template library for each resource type.
As a template library, I will assume you are referring to the documentation. Every time I want to add something new, I will just Google the name of the resource in Azure and then Terraform, and instantly I will go into I will find the first or second result from the Terraform documentation, and it's going to be there. Also, the community is pretty good. There are issues with Terraform, of course, not to say that everything is perfect, but for probably 95 of your cases, you should be okay. I've had an issue on a personal project, but nothing on my work environment, which is way more complex than my personal project.
Thank you. Great. No more questions. You can carry on.
All right. A few more slides and we'll really dive in. Azure Pipelines, for those who are not aware of Azure Pipelines, it is an offering in the Azure DevOps services. It is free for public projects and open source projects. Ideally, I'd say it's a great tool for every indie developer if you love the Microsoft ecosystem. And personally, I find myself jungling between DevOps services and GitHub, depending on what I want to do with the project. Usually, for my blog, I will opt for GitHub, but for personal projects, I will opt for for DevOps services. Also, to do that, to execute to use Terraform on your pipelines, you will not need to download the Terraform extension, but I strongly advise to do that because you don't want to mess with downloading the binary, setting Terraform to the path. You'd like to just download this extension to your work, to your organization, and then just use the task without more hassle. this is the integration pipeline I have on Azure Pipelines. It's a really simple pipeline, and all it does is to use the install Terraform task from the extension that I've shown you before. It's doing an initialization, just like we did on my local machine, and also validate the template. We don't really need anything more than that for Terraform. We don't have the need to push any artifacts. We can just grab it from the repository. Something that it is important to note here, and I've mentioned this at the start of the talk, is that when we are working with Terraform on the pipelines, we are not using our own Azure account. We have to go a different way, either with a service principal, which would be the best way to go, the best practice to go. But now here I'm using a service connection, so DevOps services can connect to my Azure subscription. The first time that you will try to set up something like that, DevOps will prompt you to create a service connection or authorize a service connection. I'm not sure, and I clicked it yesterday, but it's a 2-click step. So, okay. Why this is not progressing? Oh, okay. One moment, I got lost now. Terraform extension. Okay, here we are. The next step would be to, given that our source lives on a repository, it would be to trigger this pipeline every time that a new pull request is merged into the develop branch. So the next thing that you will do is to go into your develop branch and the branch policies and enable build validation for that specific branch. And you will select that pipeline. We'll also see that. And then to the funny part, this is the deployment pipeline. The deployment pipeline is triggered every time that, that a new pull request is completed. And it has 2 stages. It has the create stage and the destroy stage to replicate exactly what I did before. The only difference is that on the create stage, we also have the plan command. Let me see. Yep. Installing the Terraform tool, doing the initialization of storage account, planning and applying. Of course, you can omit the plan and go directly for and apply an auto approval. But I do find it helpful, and a few seconds are not an issue. Also, going back to the mistake I made before and had not passed the the variables on the pipeline, I'm also setting those variables as secrets, which will in turn be passed into the Terraform plan. And on the rightmost image, you can see the pipeline for the destroy stage. Again, I'm installing the tool, initializing the Terraform, and then running the destroy command. Also, important to note is that, again, when we are running this from Terraform and using this specific extension, the backend configuration that we have on the project file is completely ignored. And what I mean by that, let's switch to the pipelines. Here is my project. I'm going to go to the pipeline. Here it is. I'm going to click edit. So let's see the initialization task. Is it clear, or I'd better zoom in a bit?
I can see.
Great. As you can see on the lower part here, there is the Azure Resource Manager backend configuration. I'm selecting the subscription, I'm selecting the resource group I'm using, the storage account, the container, and I'm just giving the key, just like I did on the backend configuration. Of course, you can you can go the hard way, download Terraform on your own, install it, and do everything with PowerShell. But it's up to you and how complicated you want to do that. So now that I have destroyed my resource before, I'm gonna run the pipeline and create it again. I'm gonna run the pipeline that would run as if I had just merged the pull request. This will take about some seconds to execute. 19 seconds, not bad, not bad. And then I'm just going to create a release for now. A release has not been created automatically because the the developer branch had already executed that pipeline before. And you can see that the commit ID is the same here, but we will make a change with that. I'm gonna go into the releases and click deploy and approve it. Approve, approve. Has anyone noticed that DevOps is acting weird the last few days, or is it just me? Sometimes I click and it just doesn't do anything.
I haven't used it in the last few days.
As you can see, the pipeline is running. We are already in the apply stage. I did not specify. Yes, I have just used again the auto approve switch, and it's running.
While we are waiting, I can see there was a question from Stefano saying, what about testing? I'm not sure specifically what he meant. What about
I
testing?
think this requires a bit more context too.
Do you want to share the context, Stefano? Feel free to speak if you want.
Yeah, yeah, sorry. I was wondering if there is some testing mechanism that we can approach using Terraform stuff.
From which perspective? Test as to what? For example, isolated testing for a new feature that will go into production.
Yep, kind of. Yeah.
Actually, this is one of the use cases I have at the end of my presentation. Something that we are trying to start using on my team. I'm not sure if Terraform is the great tool for that, because if you have a small backlog item, you don't really want to spin up an expensive infrastructure, and you'd like probably to go with a different approach, close to spin up, test, destroy, but it's up to the team. Now that the the create stage is completed, I'm going to switch back to my dashboard, hit refresh again, and you can see that the resource group, once again, it is there. The app service plan will show up as well. Oops. I'm going to go into the web app first. You can see the configuration is there. The variables that I've defined on the pipeline are now passed to Terraform and then to my app service. Again, the same same goes for the container settings that were not working before. So let's test a different scenario where we want to update the app service. Let's say that suddenly we have a lot of usage and we have to go from V1 to P1, V2, but I will not do that. I'll just change the name. So I will switch back to my branch. I'll create a new one. .NET King. And let me think what I will change here. I'm gonna rename it from my day UI to .NET Cambridge. I'm going to commit this. I'll create a pull request. I always love it when I approve myself. I think you think the same too. Let's switch back to the pipelines here. I think I missed a step somewhere on the branch and it did not automatic. Oh, there it is. The pull request is completed. A new release is created. It's it's set to start the deployment, but wait for my approval. You never want to have something executed by that. You want to have the last click every time. So I'm going to click the approve button. And what I would expect now is that when the plan will run, it will compare the new state and the new configuration with what I have in state. And essentially what it will do, it will tear down everything and bring it up again. It will tear it down because I'm changing the name, and we cannot change the name of a resource just like that. If I just updated a setting, it would be just like before. So let's see this running. It's still destroying. As you can see, then it will start the creation of the new object, the new resources. I see there are three questions that we could check out while Terraform is creating the pipeline. Sorry, if I were to scale up an SQL server on, say, production, would you update that environment variable and do a Terraform deploy? Actually, yes, this is exactly what I will do, and this is what I plan to do next week, to be honest, on work. We have a pre-live environment which is using our the dev profile, the dev environment, and we want to scale that up to a live environment, the production environment settings, and not just recreate a new one, just to see how this will cope. Okay, now this is completed. Switching back to it, I'm gonna click refresh. And now you can see .NET Cambridge is there, and not only on the resource group name, everywhere where I was using the variable. So .NET Cambridge is the name of my plan, and the app service too. I'm gonna close this by also executing the destroy pipeline. The question from Alex SZ, can you be a bit more descriptive? I think I get what you mean, but just to make sure.
Dimitrios, do you mind repeating the question if for the people in there listening to the recording later?
It sounds like it's not exactly that, right? It's a tear down and recreate rather a change pricing tier. I think here my example was not right. Of course, you will not recreate your whole environment to just change the pricing tier. You will recreate a resource only in the case that the setting you want to change cannot be changed from the portal. And either with Terraform or with the Azure portal, they both use the resource manager underneath. So if you can do it on Azure, on the portal, you cannot do it on Terraform as well. Oh.
Yeah.
Right. I agree with you, Matt. I agree. But in the case that you have a consistent state file, you will never end up in a situation like that. Never. This is now completed. I'm going to go back to my dashboard again and refresh it. And as you can see, resource not found. Here, it's not updated yet here, but the resources are deleted. Going back to the presentation, some last piece of advice. If you opt to use Terraform or any other tool that manages your infrastructure, stick just with that and limit the number of people who can interact with your infrastructure. Many people having access to the infrastructure means that 99% of the time, they will make a change there without you knowing, thinking that it's not important. And the next time you go to execute your plan, what's the right word for that? You will be wondering what changed there. So stick to Terraform only, even for big emergencies. Let the business know that it's Terraform only, because I'm sure all of us face this thing that something is wrong in production and we have to do it in the unorthodox way. Ensure that there is team-wide knowledge and experience on Terraform. This is because if you stick to number one and you are a 5-member team and only 2 of them know how to work with Terraform and they are on annual leave, then that's bad. You can instantly tell that. Update the project as the moment you are updating, you are developing your PBI. If a new resource is if a new resource is needed, the developer who is adding the resource should be the one who will edit the project. Start using it at the end, at the start, or maybe at the end of the project. We started doing it in the middle of the project, and trying to manage 4 different environments, changing constantly is really it's hard, because from the one side we are developers and this is not our day-to-day job. We do this on the side because we want to be more flexible. And 5, always study the execution plan. Some use case scenarios: reduce your infrastructure costs, destroy your environments when they are not used. The development environment, you don't need it after 6 p.m. probably. You don't need it on the weekends. You can even do that with your live environments. So you can start thinking, cutting your costs in half, depending on your business, of course. Backlog item testing in isolation. A new PBI goes, it's developed, spin up a new environment, have QA tested. It's not as simple as it sounds, but with Terraform, it's easier to do, and using Docker, of course. As mentioned before, update the project. When you add a new resource, start using it at the start of the project. Oh, and study the execution plan. That was the same. Oh, nice. So that was the end of my presentation. I hope I have not made things too complicated for you. This was the first time that I made a more thorough presentation about Terraform. I would Really love your feedback, good, bad, and feel free to connect with me either on LinkedIn or Twitter. So thank you. And Andrea, thank you for the opportunity. If it was, sorry for saying that, but I really
Absolutely. Thank you.
I really find beautiful that in those times we are that the community, that thing with the community. Otherwise, I would be just restricted to Manchester, never be able to talk with you and meet your community as well. So once again, thank you.
No, thank you for speaking. Looks like there might be a few other questions. Feel free to speak if you want to ask directly to Dimitris. What's the best way to structure the Terraform modules in a large team to implement separation of concerns?
Not really sure how to answer that. I have not been in that place yet. The way I'm going about this is our solution includes 2 resource groups for all of our services, and so far I just have 1 module for each resource group. Maybe we don't have such a complex infrastructure yet. Maybe we have done it right, but I would like to know more about your infrastructure and how big it is, so that you have to think from that perspective.
So we've got a bunch of Terraform modules. We've got only 1 team working on it, but we've generally found it a lot easier to basically follow the single responsibility principle. So if each team should essentially have its own modules it owns, and so when you're talking about your SQL, either if you're talking about your web page, all of that's in 1 module. If that's split across teams, split it up in the same way you would with microservices or anything like that. Keep the boundaries matched to the teams as well, and just single responsibility makes it a lot easier.
So, sorry.
I think I agree with that, but I keep thinking what I mentioned about the whole team being able to interact with Terraform in any part of the project. What would happen in the case that the person managing the app service module was on annual leave? What would happen there?
So again, you still want everyone who is responsible for app service to be able to change it, and generally everyone should be able to change anything. People just generally have areas. So if your team is no more than 10 people, everyone can change everything.
Yes.
But when you start talking about multiple teams, then I wouldn't partition within a team.
And why not create a service principal for each team that will have access just to the resource groups that the team is using, and every team can use its own service principal on the same plan. That way, even if something goes wrong and you touch something that you should not touch, the service principal will restrict you. Does that make sense?
Yeah, so you can either split it up as multiple. If you can either have multiple configurations, or you can have one main configuration that pulls in a bunch of modules.
Yes.
And depending how interlinked they have to be, depends on what you need to go for. But generally, just have just have 1 entry point module for each team, and each of those would have its own service principle.
I'm getting what you're saying there about automation, because I've not been in that place yet. Have not really explored it that good.
Yeah. It will depend on your teams. Conway's law and all that. You'll want your module structure to match your team structure.
We are a team of 5, and at the moment, that's an interesting discussion to have with my team. Actually, it's a really interesting discussion to have with the team.
Hi. So the question. So Mike, the idea behind this question was, I don't use Azure, but I use OpenStack for cloud, and I use Terraform in that. And so basically, I have to manage tenancy in OpenStack. and I have so I wanted to create separate modules for separate concerns. Let's say I want to create a module for only provisioning of networks and like bastion host kind of thing. And then there is a separate module for creating different clusters. Like maybe I'm creating a Kubernetes cluster within a tenancy, or maybe I'm creating some other clusters within a tenancy. So what I wanted to do is to create separate modules for different kind of tasks. And then so each module would have different state files, and then maybe there will be some dependency between these modules. And I could have so I don't want to import state files because it could have secrets that I don't want to expose to other modules. So maybe let's say there's a team which is working on creating networks, and they have secrets, and there is a team which is working on a separate module, which is a sub module, and they're not allowed to create networks or kind of thing. So at the moment, I was thinking to just use some data modules to fetch the resources that's already there, or maybe this kind of thing.
Oh, that's a complicated one.
Yeah.
Regarding the different state files that you mentioned, don't workspaces work for that scenario?
So basically, so what we are trying to use is, so basically this. So I work with a research institute, and we have a concern of so basically we use GitLab CI/CD to use the continuous deployment, and basically we don't want to expose. So the GitLab server is a central server, and we don't want to expose our secrets there. So that's also the concern, because if we are running our pipeline in a GitLab server, that would be shared by different teams. So I don't want to expose my secrets there. That's also a concern.
What I was trying something similar yesterday. What you could possibly do? I'm going to talk with Azure terminology because I'm not familiar with OpenStack. But what I did in that case when I wanted to pass secrets that way was to use an Azure Key Vault, create a new secret there, register the key vault on the Terraform project with the data keyword, register the key that I wanted to use, and use a service principal to get this key, logging the service principal down to the key vault, and then it's done.
Okay.
But I feel that I have not answered your question, but I would really love to know more about that.